In the last video, we learned about linear equations in two variables and how to represent the equation in the general form of ax plus by plus c, and how to find those parameters or coefficients of the variables x, y, and also the constant coefficient a, b, and c, right? So we have seen those aspects of representing the linear equation in two variables in the general form. And we also talked about some of the rules that we need to remember when solving linear equations. The first rule was that if we add the same number to both sides of the linear equation, the solution of the equation is not affected. Similarly, if we subtract the same number from both sides of the equation, even then the solution of the equation is not affected. The second rule stated that if we multiply or divide the linear equation on both sides by the same non-zero number, even then the solution of the equation is not affected. Let us now move on to finding the solution of a linear equation. How do we find the solution of the linear equation with two variables? We had seen how to solve and find the solution of the linear equation for one variable in the previous lecture. Let us now see how we can find the solution of a linear equation in two variables. So we have this example of a linear equation in two variables. The variables are x and y. So there are two letters, okay? Letter x denoting one of the variables and letter y denoting the second variable. So this is an example of a linear equation in two variables. And we want to find what is the solution for this linear equation. First of all, let us recall what do we mean by the solution. The solution is nothing but the values of x and y that will satisfy this equation. So what value that we can substitute in place of x and in place of y that will satisfy this equation, and those values will give us the solution of the linear equation. So what do you think is the value of x and y that will satisfy this particular equation given here? One of the numbers that we can think of is if we put x equal to 3, 2 times 3 will become 6. And if you put y equal to 2, then 3 times 2 will also become 6. So 6 plus 6 will become 12. So that will satisfy the equation. So let's consider the values. So consider x equals 3 and y equals 2. Let's substitute this in our equation. So 2 into x. So in place of x, we are going to put 3 plus 3 into y. So in place of y, we are putting 2 equals 12. 2 into 3 is 6 plus 3 into 2 is 6 equals 12. And that is 12 equals 12. So this is satisfying the equation. 12 equals 12 is true. Therefore, x equal to 3, y equal to 2 is indeed a solution for this equation. And we generally represent the solution as a pair of numbers in the brackets. So we write it as x comma y is the solution. So what is the value of x? Which in this case, x equals 3 and y equals 2 is a solution. Okay. Is there any other combination of x and y that satisfies this equation? Clearly there is. For example, if we put x equals 0 and y equals 4, that also satisfies this equation. So let's consider x equals 0 and y equals 4. If we substitute these values into the above expression, so 2 into x, that is 2 into 0, plus 3 into y, 3 into 4, because y is 4, equals 12. So that will be 0 plus 3 fours are 12 equals 12. So that is basically 12 equals 12. So this is also satisfying the equation. So that means x equal to 0, y equal to 4 is a solution. And we write this solution in brackets as a pair of numbers 0 comma 4. The x value comes first and then the y value. So x comma y inside the bracket, and that is the values of x and y in the bracket. That gives us the solution. So we denote or represent the solution in this particular form. So the value of x that satisfies the equation, followed by the value of y that satisfies the equation. Okay, so 0 comma 4 is also a solution. Let's see if there are any other solutions. What happens if we put y equal to 0 and then try to find what is x? So if you put y equal to 0 and then x equal to 6, okay, so x equals 6, y equals 0. So in this case we get 2 into 6 plus 3 into 0 equals 12. So 2 6 are 12 plus 0 equals 12. So that means 12 equals 12, right? So again, this is satisfying the equation. So that is indeed a correct equation, 12 equals 12. And therefore, x equal to 6, y equal to 0, which we can denote as 6 comma 0, is also a solution for this linear equation. Now, let's say we take another combination of x and y. Let's say x equals 1 and y equals 4, and see if this satisfies the equation. So if we substitute in place of x as 1, so that's 2 into 1 plus 3 into y is 4, and if we equate that to 12, 2 into 1 is 2 plus 3 into 4 is 12 equals 12. 2 plus 12 is 14 equals 12. This is not true. 14 equals 12 is not satisfying the equation, right? The left hand side and the right hand side of this calculation is not the same. So this is wrong, right? So therefore, we say that 14 is not equal to 12. So therefore, 14 is not equal to 12. And therefore, our values of x and y that we have chosen, that is 1 comma 4, x is 1, y is 4, is not a solution, okay? So the other values that we have chosen, they are indeed solutions, okay? 3 comma 2 is a solution, 0 comma 4 is also a solution, 6 comma 0 is also a solution, but 1 comma 4 is not a solution for this particular linear equation. And if we keep going on, we can we can find many more solutions for this linear equation. And what we see is that a linear equation in two variables will have infinitely many solutions. We can find an infinite number of solutions, or in other words, we can find an infinite number of xy pairs of numbers that will satisfy this particular equation, okay? So what we say is that linear equations in two variables actually have an infinite number of solutions. So we need to identify what is that combination of x and y that satisfies the equation, and that gives us the solution for the linear equation. So we found out the solutions arbitrarily, okay, by observing this equation, but we need to do that in a systematic way. So when we want to approach the problem and find the solution for the linear equation, we need to have a systematic method of doing that. And one way of doing the solution or finding the solution for the linear equation is we just choose any value for one of the variables and then solve the equation for the other variable. So that will give us one particular combination. So choose any value for x and solve the equation for y. Choose a new value for x and again find a new value of y. Choose a third value of x and find the corresponding value of y, and so on and so forth. Or similarly, we can choose one value for y and find the value of x. Again, choose another new value of y and find a corresponding new value of x, and so on and so forth. And in this way, we can keep on finding infinitely many solutions for the equation. And an easy way is when we choose the values for x or y, one simple method is to choose the value of x as 0. Okay, choose x as 0 and find the corresponding value of y. Similarly, in the next step, we can choose y as 0 and find the corresponding value of x. So that will give us two solutions. One solution in which x is 0 and y is some corresponding value, corresponding to x being 0. And the second solution will be when y is 0, we'll find the corresponding value of x. And then we can go on and on about that by say the third solution could be by choosing x equal to 1 and then finding y, and then choosing y equal to 1 and then finding the corresponding x. And that way we can keep on finding many number of solutions, as there are infinitely many solutions for a linear equation with two variables. Okay, so a simple way is we will simply assign some value to one of the variables and solve for the other variable. And when we assign a value to one of the variable, an easy way is to assign that variable with a value of 0 and then find the corresponding value for the second variable. Okay, and in this way we can find at least two simple solutions where in one case x will be 0 and y will be the corresponding value for y, or y will be 0 and then we can have the corresponding value for x. Okay, let us try to find some solutions for these given equations. And we have already stated that the number of solutions for a linear equation in two variables is infinite. So we have an infinite number of solutions for a linear equation in two variables. Okay, so there are infinitely many solutions. Of course, we are not going to find all the infinite solutions. We will find some of the solutions. For example, in this particular case, we want to find two solutions for each of these following equations. So when we are asked to find only two solutions, an easy way is first make x equal to 0 and then find y, and then make y equal to 0 and then find the corresponding x. So what we will do is to find two solutions, put x equals 0. So when we put x equal to 0 in the above equation, so in place of x we put 0, 4 into 0 plus 3 into y equals 12. 4 into 0 is 0 plus 3 into y is 3y equals 12. So that's basically 3y equals 12, or we will get y equals 12 divided by 3, which is nothing but 4. So the solution is when x equal to 0, we get y equals 4. So the solution is, let me write here in red. So when x equal to 0, we get y equal to 4. So we write the solution as x comma y. So x is 0 and y is 4 is the solution, is one of the solution for this particular linear equation. Now what we do is, just as we had put x equal to 0 here, we can similarly put y equal to 0. So the next step is put y equal to 0 and solve for x. So when we put y equal to 0, we will get 4x plus 3 into 0 equals 12. So 3 into 0 is 0. So 4x plus 0 equals 12. We can simply write that as 4x equals 12, or in other words, x equals 12 divided by 4, which is equal to 3. So our solution is going to be, we have to write this as x comma y. So we write the value of x first and then followed by y. So the value of x here is 3 and the value of y that we chose to find that x is 0. So we write always, when you're writing the solution, always it is the value of x comes first and then the value of y. So x in this case is 3, so we have to write it as 3 comma 0. So the value of x is 3 and the corresponding value of y is 0. 3 comma 0. Here 0 comma 4. X is 0, y is 4. So clearly we can check whether putting these values in the equation indeed satisfies this equation. So when we put x equal to 0 and y equal to 4, we'll get 4 into 0 is 0 plus 3 into 4 is 12. So 0 plus 12 equals 12. 12 equals 12. Left hand side and right hand side agree with each other. So therefore this is indeed a solution. Similarly, if we put 3 comma 0 in the above equation, when x is 3, 4 into 3 is 12, plus 3 into 0 is 0. So 12 plus 0 is 12. And on the right hand side, we have 12. So the equation agrees or satisfies. So 3 comma 0 is also a solution. So a simple way is when we need to find only two solutions, a simple way is to just make one of the variable as 0 and find the other variable. So we made x equal to 0 and found the corresponding y. And then we made y equal to 0 and found the corresponding x. But be careful when you're writing the solution as a pair of numbers. You should always remember that the value of x comes first and then the value of y, okay? Especially when you're dealing with this situation where you assign the value of 0 to y and then find x. Don't write it as 0 comma 3. That is wrong, okay? The notation is always x comes first and then comes y. So x equals 3, y equals 0. 3 comma 0 is a solution for this equation. But 0 comma 3 is not a solution. If you put 0 comma 3, 0 for x and 3 for y, the equation will not be satisfied. 4 into 0 is 0, plus 3 into 3 is 9. So 9 equal to 12. That's wrong. 9 cannot be equal to 12, right? So you have to be sure how you write this answer as a pair of numbers where x comes first and then comes y. Okay, so we have found the two solutions for this equation. Similarly, we can find the two solutions for this as well. So again, an easy way is we'll just put x equal to 0. Put x equals 0, and then what we get? 2 into 0 plus 5y equals 0. So 2 into 0 is 0. 0 plus 5y is simply 5y equals 0. So that means y equals 0 divided by 5, which is equal to 0. So one of the solution for this is when we put x equal to 0, we get y also to be equal to 0. So x equal to 0, y equal to 0. So as a pair of numbers, it is 0 comma 0. Okay, that's one solution for this equation. Now if we put y equal to 0, so okay, when we put x equal to 0, we are getting y equal to 0. And when we put y equal to 0, we are also going to get x equal to 0 in this case. So put y equals 0 and see what we get as a solution for this. When you put y equal to 0, we will get 2x plus 5 into 0 equals 0. That means 2x equals 0, and that basically implies x equals 0. So the solution now is again x comma y. So x is 0, y is 0, so 0 comma 0, which is the same as this, right? So this, we have found the same solution again. Okay, but we want to find two different solutions. So putting x equal to 0 and finding y gives us 0 comma 0 as a solution, and similarly putting y equal to 0 and finding x also gives us the same solution, 0 comma 0. So if we want to find a different solution for this, we can choose a different value for x or y rather than 0. So let's say put x equals 1 and then solve for y. So if you put x equal to 1, 2 into 1 plus 5y equals 0. So 2 into 1 is 2. So 2 plus 5y equals 0. 2 plus 5y equals 0. Or in other words, 5y. If we take the 2 to the other side, it becomes minus 2. So now we can write that as y equals minus 2 over 5, right? So we're just moving the 5 to the other side and we find y. So when x equal to 1, y equals minus 2 by 5. So we can write the solution as a pair of numbers in brackets, as the value of x comes first, x equal to 1, and the value of y is minus 2 by 5. So that's minus 2 upon 5. So that's the second solution, okay? So now putting x equal to 0 and finding y, and putting y equal to 0 and finding x, that is giving us the same solution 2 times, okay? So one of the observations that we see from this particular example is that when we have an equation, a linear equation represented as in this form, where the right hand side is 0, 2x plus 5y equals 0, okay, and there is no constant term on the left hand side. In that case, you will find that 0 comma 0 is always a solution, okay? One of the solution for this will always be 0 comma 0. If you put x equal to 0, y equal to 0, this equation should satisfy. And that is true only when the equation has ax plus by plus c equal to 0, where the plus c is missing here, okay? That means c equal to 0. In that case, 0 comma 0 will be one of the solutions for sure, okay? So x equal to 0, y equal to 0 is a solution in this particular case. Okay, now let's look at this third example and find the solution for this. However, what you notice is that in this third example, there is no x, okay? This seems to be like a linear equation in only a single variable, okay? So we first have to represent this as a linear equation in two variables. So since there is no x here, so we will write that as 0x plus 3y plus 4 equals 0, and we can simply write that as since there is no x, okay, this is simply 3y equals minus 4. So we're taking the plus 4 to the other side, and we have the 0x in front of us, okay? So 0x plus 3y equals minus 4. Now, the x, since it is 0x, it means it is 0. 0 plus 3y equals minus 4. So y will always be minus 4 divided by 3. So irrespective of the value of x, it doesn't matter what is the value of x, the value of y is always minus 4 by 3. So to find the solutions for this, we want to write x comma y as the solutions, right? X comma y, that's one solution. X comma y is the second solution. In all the solutions, the y value is always going to be minus 4 by 3. Here also it is minus 4 by 3. And like that we can keep on making many more solutions. Each time the value of y is minus 4 by 3. However, since there is no x in this equation, we can put any value for x, and for any value of x, the value of y is always going to be minus 4 by 3. So all the infinitely possible solutions, infinitely many solutions that are possible for this equation, all of them will have the y value as minus 4 by 3, irrespective of the value of x, because the x term is not present in this equation, so the coefficient of x is 0. So we can have different values of x. For example, we can put x equal to 0, x equal to 1, x equal to minus 1, or we can have x equal to minus 3 by 7, and y will be minus 4 by 3, and so on and so forth. So we can have infinitely many solutions in this case, where the value of y will remain fixed at minus 4 by 3, and we can have any other number as the value of x, okay? Because the variable x is not present in this equation, which indicates that the coefficient of x is 0 in this linear equation. So that means that the value of x can be any number and the value of y is a fixed number. Okay, so we have seen three possible variations of linear equations in two variables from which we can find the solutions. Okay, so these are the second and third one are quite interesting. So if we have equal to 0 without the constant term on the left hand side, and if the right hand side is 0 without the constant term on the left hand side, then the value pair 0 comma 0 will always be a solution for that equation. And when we have one of the variables missing, then the solution will be having that missing variable to be of any arbitrary value, and the variable which is present, that can be found by solving this equation. So we have just moved the 4 to the right hand side, so it becomes minus 4, and then 3y equals minus 4, and from that we find y as minus 4 by 3. Okay, so this is also quite an interesting perspective. Okay, so we have 0 comma minus 4 by 3, 1 comma minus 4 by 3, minus 1 comma minus 4 by 3. We can have minus 3 by 7, minus 2 comma minus 4 by 3, whatever. So the x numbers, each of these numbers for x can be anything. Okay, we can have 0, 1, minus 1, minus 3 by 7, or for that matter any other number. So you can find infinitely many possible solutions. In each case, the value of y will remain fixed at minus 4 by 3. Only thing that will change in this case is the value of x. Okay, now let's move on to the exercise and look at the problems in the exercise. So we are given this equation, question number 1. We are given this equation and we are asked to choose which of these following statements is true regarding this equation. Okay, what do you think? Does this equation have a unique solution, or does it have only two solutions, or does it have infinitely many solutions? First of all, what kind of equation is this? Is this a linear equation in two variables or not? Clearly, this is a linear equation in two variables because we have a variable x and we have a variable y. So this is indeed a linear equation in two variables, and we have already stated earlier that a linear equation in two variables has infinitely many solutions. So this equation is going to have infinitely many solutions. Of course, some of the solutions we can write down. So basically, since it is y equals 3x plus 5, all we have to do is give different values for x and find the corresponding value of y. And each of that combination for x and y will be a solution. So let's say we put x equal to 0. Okay, when we put x equal to 0, what do we get for y? We get y equals 3 into 0 plus 5. 3 into 0 is 0. So we're just putting x equal to 0 here. In place of x in the equation, you're putting 0. 3 into 0 plus 5. So that will give us 0 plus 5, which is 5. So when x equal to 0, y equal to 5. So the solution is 0 comma 5 is the solution. Similarly, you can just say x equal to 1 and find the corresponding value of y. So y equals 3x. So in place of x, we put 1 plus 5. So 3 into 1 is 3 plus 5 is 8. So when x equal to 1, y is equal to 8. So the solution is 1 comma 8 is also a solution. Similarly, we can have let's say x equals, let's say, minus 1 and find the corresponding y. So the corresponding y will be y equals 3x. So that's 3 into minus 1 plus 5. So what is 3 into minus 1? That is minus 3 plus 5. This is the same as 5 minus 3. Okay, so minus 3 plus 5 is equal to 2. So the solution is minus 1 comma 2, x comma y. X is minus 1, y is 2. Or we can just put y equal to 0 and solve for x, and we can go on and on. So each time we can just put some value for x and find the corresponding value of y, and each of those xy pairs is going to be a solution for this equation. So we can choose infinitely many possible values for x and find infinitely many possible corresponding values of y. So the correct answer here is the equation has infinitely many solutions. So the correct answer, I will tick it with a red tick here. So the correct answer is infinitely many solutions. Okay, so let's move on to the next question. For this, we are asked to find 4 solutions for each of the following equations. Okay, so the method is fairly straightforward. We can find the first 2 solutions by setting one of the variable as 0 and finding the other variable. So we will put x equal to 0 and find y. So when we put x equals 0, okay, what happens to this equation? It will be pi times 0. So in place of a number, we have a constant here, pi, which is 3.14 something answer. Okay, so that's pi times 0 plus y equals 9. So pi, anything into 0 is 0. 0 plus y is simply y. So y equal to 9. So y equal to 9. So that means the solution is 0 comma 9 is one of the solution of this particular equation. The second solution is we can put okay, let me write here also, put x equal to 0. So now we can put y equal to 0 and find the corresponding value of x. So when we put y equal to 0, we get pi times x plus y. So in place of y we put 0 equals 9. So that is simply pi times x equals 9, or we can simply say x equals 9 over pi. Okay, of course pi is 3.14. 9 divided by 3.14, we can just leave it as this. Okay, we can leave it as x equals 9 by pi. So when y is 0, x equals 9 over pi. So the solution is we have to write it as x comma y. So x is 9 over pi and y is 0. So that's also a solution. And likewise, we can find 2 more solutions. So another simple way is just as we put x equal to 0 and y equal to 0, we can now choose x equal to 1. Okay, we know we need to pick simple numbers so that our calculations will be easier. So if we choose x equal to 1, then what happens? So that becomes pi into 1 plus y equals 9. So that will be pi plus y equals 9. Or in other words, we can simply write y equals, we take the pi to the other side, 9 minus pi. So the plus pi from the left hand side, when it goes to the other side, it becomes minus pi. So when x equal to 1, y equals 9 minus pi. So that is 9 minus 3.14, which will be 5.86 something, right? So we'll just leave it as 9 minus pi. So we can write it as x comma y. So x is 1, y is 9 minus pi. Okay, so that's one solution. So that's the third solution. Another thing that we can do is we can choose a value of y to be equal to 1. So again, I'm going to write put x equal to 1. So the fourth thing is put y equal to 1 and then find x. Okay, so it will be pi times x plus, in place of y we put 1, equals 9. So that will be pi times x equals, we take the 1 to the other side, it will be 9 minus 1, so that will become 8, or x equals 8 divided by pi. Okay, so the solution is going to be x comma y, which is 8 by pi comma 1. So x equals 8 by pi, y equals 1. Okay, so we have four solutions. The first solution is 0 comma 9. The second solution is 9 by pi comma 0. The third solution is 1 comma 9 minus pi. The fourth solution is 8 by pi comma 1. And like this, we can put any value for x, find y, or put any value for y and find the corresponding x, and we can keep going on and on to find infinitely many solutions. Okay, so we have found four solutions here because we're asked to find four solutions for these equations. Okay, so we have the four solutions that are required for this particular equation. Okay, now let's move on to this next question. We need to find four solutions for this equation, and this is quite simple. It's in the form of x equal to 4y. So all we have to do is give different values for y and find the corresponding x, and each xy pair will be a solution. So we're just going to put y equals 0. So when we put y equal to 0, what is x? X equals 4 into 0, which is 0. So the solution is x equal to 0, y equal to 0. So 0 comma 0 is a solution. We can put y equals 1. So in this case, what will be x? X equals 4y. So 4 into 1, which is 4. So the solution is x comma y, which is 4 comma 1 is a solution. Okay, similarly, to find the third solution, we can put y equals, let's say, 2. Again, we can choose any value for one of the variable and find the other variable. So in this case, we are putting y equals 2. Corresponding value for x will be x equals 4 times y, which is 2, and 4 into 2 is 8. So the solution is 8 comma 2. So x is 8, y is 2. We can also choose negative values for any of the variables, so there is no harm. We can choose any arbitrary value for each of the variables. So let's say we put y equals minus 1. Okay, when we put y equals minus 1, what do you get for x? X equals 4 into minus 1. 4 into minus 1 is minus 4. So the solution here is x comma y, which is x is minus 4, comma y is minus 1. So minus 4 comma minus 1 is a solution for this equation. Again, once we have found the solution, to check if this solution is correct or not, substitute the x and y in the equation and see if the equation satisfies. So we said 0 comma 0 is a solution. So when we put x equal to 0, the left hand side is 0, and y equal to 0 for the right hand side. 4 into 0 is 0, so 0 equals 0. So left hand side equals right hand side, so therefore this is a solution. Similarly, if you put x equal to 4 and y equal to 1, so for x equal to 4, the left hand side is 4, and for y equal to 1, the right hand side is 4 into 1 is 4. So left hand side is 4, right hand side is 4 into 1, 4. 4 equals 4, that is left hand side matches with the right hand side. So therefore this is indeed a solution. And likewise, we can check for all the other solutions. So 0 comma 0 is a solution, 4 comma 1 is a solution, 8 comma 2 is a solution, minus 4 comma minus 1 is a solution, and so on and so forth. When we put we can also put y equals minus 2, and then the corresponding value of x will be minus 8, and so on and so forth. Okay, so we have found the four solutions that are required as per this question, and we can find many more solutions if we like. Okay, the procedure is the same. All we have to do is fix the value for one of the variables and compute or calculate the other variable from the given expression. Okay, now let's move on to the next question, which is also fairly straightforward. All we have to do is check whether these xy pair numbers that are given to us are a solution for this particular equation or not. So all we have to do is we have to substitute these numbers in each of the equation, these numbers in the equation, and check if the equation satisfies or not. So for the first one, we are going to substitute 0 comma 2 in the equation. So in place of x, we are going to put 0, and in place of y, we are going to put 2 and see if the equation is satisfied or not. So our equation is x minus 2y equals 4. So in place of x, we have 0 minus 2, and the value of y is 2 equals 4. So the left hand side is 0 minus 2 into 2. So 0 minus 2 into 2 is 4. So that's minus 4 equals 4. Well, on the left hand side, we have minus 4. On the right hand side, we have plus 4. And they are not equal. So this equation is not satisfied. So we just say minus 4 equal to 4 is not satisfied. That means this is not equal, right? So therefore, we will say that therefore 0 comma 2 is not a solution. Okay, so let's check if the second solution 2 comma 0 satisfies the equation or not. So the second solution is 2 comma 0. So we will substitute in the equation again, x minus 2y equals 4. So in place of x, we put 2 minus 2 into 0 equals 4. So x minus 2y, x is 2, and minus 2 times y, y is 0. So 2 into 0 is going to be 0. 2 equals 4. So this is now saying 2 equals, the left hand side is 2, the right hand side is 4. Is this correct? It's not correct. Okay, 2 cannot be equal to 4, so the equation is not satisfied. So we say 2 is not equal to 4. Therefore, we will say that 2 comma 0 is not a solution. Okay, let's check the third number here. So I'm just going to draw some lines here to separate the solutions. Okay, so let's look at the third number that is given to us, which is 4 comma 0. Okay, let's see if this is a solution or not. So our equation is x minus 2y equals 4. So in place of x, we put 4 minus 2 into y is 0 equals 4. So 2 into 0 is 0. So 4 minus 0 is 4 equals 4. Hurrah, that's correct. 4 equals 4. Left hand side agrees with the right hand side. So this is indeed correct. So therefore, we can say that 4 comma 0 is a solution. Okay, so this is how we check if a given xy pair is a solution or not. We just substitute those values into the equation and see if the left hand side and the right hand side match. If they match, it is a solution. If they don't match, then that particular xy pair is not a solution. Okay, so let's do the fourth one. The fourth point given to us is root 2 comma 4 root 2. Okay, let's substitute these into the equation. So our equation is x minus 2y equals 4. So in place of x, we are going to put root 2 minus 2 times y is 4 root 2 equals 4 on the right hand side. So let's verify if the left hand side matches with the right hand side. If the left hand side evaluates to 4 and we have 4 on the right hand side, that means it matches, right? So that will be square root of 2 minus 2 into 4 is 8 times root 2 equals 4 on the right hand side. So is this correct or not? Let me draw that line clearly. So this will just simplify to root 2 minus 8 root 2 is basically going to be minus 7 root 2 on the left hand side. So that's minus 7 root 2 equal to 4. Okay, is this correct? It's not correct. So on the left hand side we have minus 7 times root 2. On the right hand side we have 4. So this is incorrect. Okay, how did we get minus 7 root 2? This is root 2 minus 8 root 2. It's like x minus 8x. Okay, 1x minus 8x is minus 7x, right? So I'm just considering root 2 as x. So x minus 8 times x is minus 7 times x. Okay, so on the left hand side we have minus 7 root 2. On the right hand side we have 4. So the equation does not satisfy. So therefore we will say that root 2 comma 4 root 2 is not a solution for this equation. And let's do the final point and see whether 1 comma 1 is a solution or not. So the final one is 1 comma 1. So we have our equation x minus 2y equals 4. So in place of x we're going to put 1, and in place of y also 1. So 1 minus 2 times 1 equals 4. So that's 1 minus 2 equals 4. That's 1 minus 2 is minus 1 equals 4. Oh no, 1 minus 1 cannot be 4, right? So that means this statement is wrong. So therefore 1 comma 1 is not a solution. Okay, so this is how we check if a given xy pair is a solution or not. All we do is substitute those numbers of x and y into the equation and check whether the left hand side and right hand side agree with each other. If it agrees, then that point is a solution. Otherwise it is not a solution. So in this case, out of the 5 solutions or number pairs that are given to us, only one of them happens to be a solution, which is 4 comma 0. All the others are not a solution. Okay, now let's do one final example, and this is also very straightforward. We are given that x equal to 2, y equal to 1 is the solution. So if we write the solution as a pair of numbers in the bracket, so x is 2, so that's 2 comma y is 1. 2 comma 1 is a solution of 2x plus 3y equals k. So if 2 comma 1 is a solution, that means it must satisfy this equation. So all we have to do is substitute 2 and 1 in place of x and y into this equation and solve for k, and that will give us the value of k, which is what we have been asked to find. Find the value of k given that x equal to 2, y equal to 1 is a solution for this equation. Okay, so the procedure is substitute two comma 1 in the equation, and that's in the given equation, and solve for k. Okay, so we have 2x plus 3y equals k. So in place of x we are going to put 2, so that's 2 into 2 plus 3 into y. In place of y we will put 1, and that will be k. Okay, so 2 into 2 is 4 plus 3 into 1 is 3 equals k. So that means 4 plus 3 is 7 equals k, or in other words it simply means that k equals 7. Okay, so the value of k is 7, and we can verify whether this is true or not. So if we have 2x plus 3y, we have found the value of k as 7. So if you put in place of k 7, and then since we are given that 2 comma 1 is a solution for this equation. If you put x equal to 2 and y equal to 1, it should give us, the left hand side should evaluate to 7. Okay, so if you put 2 into 2 plus 3 into 1 equals 7. So that's 4 plus 3 equals 7. So that's 7 equals 7, right? So which is indeed true. So we have the value of k to be equal to 7, and we also verified that with the value of k equal to 7, the given solution 2, 1 is indeed a solution, because the left hand side matches with the right hand side of the evaluated equation. Okay, so it's a very simple and straightforward topic. So finding the solutions for linear equations is two variables. The method is to simply assign a value to one of the variables and compute the other variable. So we can choose any value for one of the variables and find the corresponding other value. And an easy way is to first assign x equal to 0 and find y, and then assign y equal to 0 and then find the corresponding x. If we need only two solutions, if we need more solutions, we can assign different values like x equal to 1, find y, and then y equal to 1, and then find the corresponding x, and so on and so forth. Okay, so the procedure is to simply assign a value to one of the variables and find the other variable by solving the equation. Okay, so that brings us to the end of chapter 4, which is on linear equations in two variables, and we will move on next to the next chapter. And I hope things are quite clear and you're able to follow what's going on, and you're able to understand the concepts here. If you have any questions, do write your questions in the comment section, and I'll try to answer those questions as soon as possible. Please do like and subscribe and share this channel so that more and more people can benefit from these lectures.